welcome. Today I would like to present you this demonstration of this unit which can surely help you to compile a mathematical formula in runtime. For example, you need to plot a function, however you don't know it until runtime, which means it's the user who answers the mathematical formula during runtime, and the application executes it as if it is really compiled. To understand the importance and the utility of this unit, I would like to show you this small demonstration. For example, here now we declare our unit which allows the application to use the formula and to compile the mathematical formula, and then we need to create a T formula object. Here we create a variable called T formula 1 of the type T formula, and as any object we need to create it. We create it when the form is created. Here we create the T formula. We create a T formula object and we assign it to T formula 1. Then we create a variable, a table of variables. The table of variables. We create a table of variables and assign it to our formula. Well, I didn't make it automatically because sometimes we need to share a table of variables between many formulas. So anyway, this is not very important in our demonstration. Now we have to add or to declare a new variable in this table. We created and we call it x, and it holds the index 0 because it's the first variable in our table. And then how we use it, here we have, for example, this labeled edit well. We have to edit our formula, and when we create when we click on the button run, anyway, we have many things to initialize, but this is not very important to explain this. Which is very important is this line. In this line, for example, we have to compile the formula which has the type string. So we take this string from the labeled edit text and we compile it. We don't need to initialize the variables before we don't need to initialize the variables before compiling the formula. So after that, now we have to we answer to the loop which executes this formula. But at any time we execute a formula, the value of the variable will change, and we don't need to recompile the formula. So it's compiled just one time. What we need is to change its value. For example, here we have a variable which is called x. It's not the same as the index of the variable. It's not the same as the variable which is declared in our table. But now we assign the value of the x variable to the x variable which is in the table of variables and which holds the index 0. And at every time we execute the loop, we have to compute the new value. The new value will change according to the value of the variable, and we get it. The variable y will hold its value, and we add it to the series. And it's not very important. The very important line is here. We compile it, and then we change the value of the variable, and we get the result, the new results, by executing the function called compute, and we get the results. For example, now we do this small demonstration. For example, as you see, this is the application. We answer for example, this function, which is, for example, we make, for example, 1,000 points, and I would like, for example, to plot the function which is sine x times 10 times, for example, exponential minus x times 0.1, for example. Yeah, so it's like that. If we change the scale, for example, make for example 5. Yeah, anyway, for example, if we execute this this procedure step by step, we click here, we get, for example, yes, here we see that the label edit one text is sin x times 10 times exponential minus x times 0.5. Yeah, we computed, we compiled it, sorry, yes, and now we have the variable x, it holds the value minus x, which is 0, and we assign it to the variable inside the table of variables, yes, and we get the new results, yes. And every time we change here, every time we change the value of the variable x, the result changes, and we continue until